This year at Tyndall Technology Days, we're grappling with two very important challenges. We're all familiar maybe with the term Internet of Things, how devices are being connected, how it's going to change people's lives. And that's all fine and well until you get down into the details, and let's discover how we do that. There are two really important challenges that you have to face. When you power all these devices, connect all these devices, you have to think about where's the energy for all that going to come, and how much of the world's energy is actually going to end up being consumed by the Internet. So one of the strands today is around power efficient devices, effectively changing the way we design hardware to be much more power efficient. Second challenge then is connecting the Internet of Things. So as we think about giving up control of our car, for example, in autonomous driving, then you start to think about how secure is that transmission, how reliable is it? And so issues like latency and bandwidth become very, very important. You don't want the timing to be wrong when that car has to make a decision that you formerly made.
What I talked about is really giving a preview of ADI perspective in terms of where IoT is going, and specifically where we have razor focus effort in developing our foundational capability, going beyond our excellence in sensing and measurement through our components, but really having a deep domain and application focus in optimizing low power solution, extending to specific businesses in healthcare, smart city, smart consumer, and smart industry.
Talking here today about energy harvesting sensors. So the sensor only wakes up when something is happening that's not normal. Let's say, so if there's a vibration, then the sensor wakes up and starts to either do that analysis at the edge, at the device level at the edge, and then sends a message up to the cloud, or it sends a message straight to the cloud depending on the severity.
Well, it's true that for the Internet of Things, every individual small sensor has to have its own power source. And so we can't feasibly think of a little battery for running everything. It has to be done in a smarter way than that. But at the communications across the internet and also at the storage end, power is also an issue. So it really is. Power scaling is actually a big part of the new ways we look at the scaling in the roadmap, and how we manage the power for the whole system is becoming of increasing importance.
We are focusing primarily on how to get the devices to operate at a lower power, and we also would like to increase the possibility to use renewables and get energy from the environment. And so this is a big balancing act. One of the things we're looking at is trying to adapt things from our environment, such as the fluorescent lights, and things like thermal energy from the body, things in motion, they can generate energy. So we're trying to get the radio technology, which is a key primary enabler, very low power, so that we can bridge those nodes and get the information to the gateway.
Enjoy this video? Click here to get the latest news from SiliconRepublic.com and go find us on social media.